Many years ago, when we started doing research with PRF, we did not know as much as we do today. Once again, we thought red cap tubes are all the same, white or orange caps are all the same. And over the years, we've realized how big of a difference and how impactful these actual tubes are. Today, we see companies that will advertise their tubes as being chemical free, and in fact, there will be chemicals inside them. We see many clinicians that utilize tubes that are meant for laboratory use, and they try and use them in clinical use as well with negative outcomes. So this course right here is really to highlight, what is available today in platelet-rich fibrin tubes. What have we learned so far based on all the research that's been leading up to 2020, and how it can impact your practice. So when we get started in this course, as we saw previously, I want to talk more and just reiterate the difference between the tubes. Red top tubes are hydrophilic tubes. Okay, they're water loving. These are typically made out of glass or silica coated plastic. And I'll talk more about the advantages of glass versus the silica coated tubes. And then on the other side, we have hydrophobic tubes. These are plastic tubes. These are not as effective for clotting. And what happens is it stays liquid longer. Now, first things first, when we look at differences in tubes, okay, I just want to go over this very, very briefly. First thing, a lot of times you might not know what kind of tubes you have. So very simply, when you bang the tubes together, okay, you can tell right away that's plastic. If you do the exact same thing with glass tubes, okay, you can tell right away it sounds like two marbles are banging against each other. You can tell right away they're made out of glass. That's trick number one. Number two, you can actually look at the tubes themselves, and you can actually see that sometimes you'll find chemical additives on the inside of the tube. So if you look closely, sometimes you can see kind of a coating on the inside of the tubes. Be cautious of that, and I'll explain kind of the water tests that we've kind of invented as a quick and easy way to test and see what's inside your actual tubes. So we realized in 2017 with some of our research that PRF tubes was very critical. Okay, so we knew that back in 2017, we learned that the glass was performing better than the plastic or the silica-coated plastic. And from there, we went on and did a whole bunch of research. Now, this is a video that I want to play just to illustrate how important these actual tubes are. So we're just going to do a small little experiment. It's just basically to talk about what's inside the tubes and what you can find from doing a simple little experiment. So this right here is obviously the butterfly needles that everybody's familiar with, that people use. Of course, the way that it works is, you pull off the cap, very straightforward, goes into a vein. When it's in the vein, there's blood. This has a vacuum. When you connect this to this, of course, what happens afterwards is the vacuum sucks out the blood. You can do the same thing with water. Okay, so you can put this in, and we'll do a close-up here. So if I put that in water, right, and then I connect this to this, I can basically see the flow that's going to occur of water into the tube. Okay, so these are the same thing as the intraspin tubes. When you fill up that with water, you can see, okay, it looks good and everything's fine. Okay. Now there's different types of tubes for the membranes, and that's where you see a lot of differences. So here we have some of the APRF tubes. I'm just going to compare a couple of different tubes. Here's some of the intraspin ones that we have here, different types of APRF tubes and over the years. So here's the most recent APRF tubes that have been utilized. Now when we look at this, still in the container here, when we take these out, okay, these right here, what you find is that in a lot of these tubes that make the membranes, whenever they go in, look at that, okay? It makes all this soap-like product, okay? That's, pretty disgusting, of course, if you're going to use this in a patient. And that's not a, random tube. I can take any of these tubes that we have. That's just basically whatever's on the walls there, the silica or whatever. Again, the tube, whenever it goes in, okay? Same thing as it's going in, okay? Okay, and that hasn't always been the case. One of the issues that we have, and of course I'm going to show some of these videos to the FDA just because I want to make them more aware of, the glass tubes. Some of the older APRF tubes. So here's an older one, APRF. Again, some of these were actually back in the day. Again, when you look at the year, look, they expire in November 2017. So I still have access to a few of these whenever we open these here. Let me just open it here. You know, some of these were made out of pure glass. And of course, if they're made out of pure glass, okay, as it's going in, look, I can shake it. Okay, when you look at it, okay, maybe there's a little bit there. Okay, but of course, much, much, much better. Again, these tubes here, these ones here are recent. So again, 9/2020 is when they expired. Okay, again, these tubes here, you know, and that's one of the issues that I have with different types of companies is that some of this stuff's not being fully regulated properly. Okay, again, that's the one 2020. Look at all the bubbles that it's forming. You know, this is supposed to be a tube that has nothing in it. That was one thing that we saw, and it kind of shocked a lot of researchers like myself working around in the industry, was that some companies were starting to change tubes, change manufacturers, and all of a sudden around the year 2018, 2019, different colleagues were calling each other and saying, hey, have you noticed that there's chemicals now inside these tubes? And many clinicians, practitioners were complaining of the contamination that was occurring in some of these tubes. So here you see here a post that was just made on social media. And of course, this is simply social media, so always take it with a grain of salt. But it says here, anyone using Chacroun's PRF system have experienced any increased risks of infection or increased pain versus non-PRF use. Myself and another friend have experienced that with quite a few procedures, although similar procedures were consistently performed well without PRF. We're puzzled and want to see what you all think. And sure enough, this had a massive amount of comments, 170 comments, and you can really see that the field has really drastically been kind of shook up by this because, again, some of these tubes are used for laboratories and people are using them for clinical use, and of course it's causing a lot of inflammation. And then this comes back to the Japanese colleague that's done just a fantastic amount of work. Shortly thereafter, he published this article, Evidence for Contamination of Silica Microparticles in Advanced Platelet-Rich Fibrin Matrix Prepared Using Silica-Coated Plastic Tubes. And in this work, what he found was that he was taking PRF that was being produced, and then with the PRF clots, he was actually degrading all of the PRF, okay? So degrading everything, only left over was the platelet-rich, basically the silica off the walls. And from the silica, you can see here that this is what's being left over inside the PRF membranes, and this is what's being transplanted back into patients. One thing that's a little bit shocking, of course, we've done research with some of these companies for a number of years. Look at the difference in tubes that are produced from 2014, 15, 16, 18, and then 2020 here, and you can see over the years, the tubes have actually changed. They've changed in colorations, packaging, manufacturing, on and on and on. And the problem is that most of this stuff, at least in the United States, is not FDA regulated. And of course, we have differences in outcomes as a result. One of the things with the most recent tubes is that the companies claim that they're silicone addition. And of course, we've launched a number of research projects as a result. When I first launched that first tube, many people were making comments that in fact, the little bubbles were being created as a result of the vacuums, etc. I created this little water video that you can do at home where you basically just fill up the tubes with a little bit of water halfway up, and then you vigorously shake it. And if you find that the foam will occur thereafter and you have foam, then of course it's not from the vacuum. So I'll just play this little video here just to show people what can be done. It's just another little video just to go over the tubes because a lot of people have been asking questions, is it related to the pressure of the tubes, etc. And I just want to do another little small experiment that you can do just to figure out what kind of tubes you have. So here we have the plain plastic tubes, and of course we have PRF tubes that have silica inside of them. Or other types of chemicals. So very easily, if you want to figure things out, you can just pop the lids, okay? And you can hear the vacuum, so you can hear it. Just actually add just a tiny little bit of water. When you add water inside there, okay, then what you can do is just put the lid back on, shake it, and you can vigorously shake it if you'd like, okay? And you can actually see inside the tube, you know, there's nothing that's obviously coming off. Again, these are some of the PRF tubes that are from 2020, so they're relatively new. And again, the batch on these guys here is 18-10-GA, so it's more of the recent one. So we can open these. Okay, again, what we can do with these ones here, same thing. So you can pop the seal off, you can hear it, and just put a little bit of water in there. okay? And then you can vigorously shake and figure out if there's anything off the walls, okay? So if you look at that, take a look at that. Okay, that's when you can really see that there's obviously stuff that's coming off the wall. And that's going into your patient, okay? Similarly, you can grab the other tube from the same batch. If you want, you know, I can just do a small little demo just to further illustrate this. If I shake this vigorously, right, again, look at what's being produced off the wall, okay? If I rinse this out, okay, I can go ahead and rinse this a few times and basically remove everything off the walls just to really clearly show that it's, you know, whatever additives are added inside some of these tubes. And that's why it's very important to make sure that you're using products that are within the FDA clearance, the Class 2 medical device. So look at there, okay? Now, because everything's gone, look, if you don't see anything. If you let these sit for a little while, you'll see the bubbles will be removed. So if I grab all these 3 tubes here, I'll take a little bit out of this one here. And I'll just make sure. So this is the first one that I've removed it. There's the second one. And here's the white tube, okay? So again, I can shake these again. Okay, take a look at that. The difference is that's one that has not been cleaned out. Okay, so there's really a huge difference. Like I said, it's a very simple test you can do with whatever tubes you're buying just to figure out what's actually inside your tube. Okay? It's totally disgusting, like I said, what's coming out of these ones. So again, that's a nice little test that can be done. And it basically just highlights the fact that a lot of these companies now have chemical additives inside their tubes, which is either foaming up and doing different things. So in this next video, what we've done is we looked at this data and we understood that we had to understand PRF tubes much better. You'll see here there's 8 different types of tubes. You'll see that there's different plastic, there's different glass. The glass coloration's different. Some of the glass has silicone in it, some of the glass has silica in it, different concentrations of these different products. And we started doing research to better understand this. And from that, it led us to develop the BioPRF tubes. All of our tubes now are obviously chemical free, both the plastic as well as the glass. And I'm gonna go over this video rather rapidly, and I'm just going to skip over some of the sections just so we can go over it. So here what I'm doing is I'm just explaining what's going on with respect to the tubes, all the research that we're doing. And what I've done in this video is I've done a full, it's a 20-minute video. Of course, I'm not going to play the whole thing here. But in one video, which is available on YouTube, I've basically taken 2 intraspin tubes here, okay, and 2 PRF tubes, the ones that have the silicone, and 2 of the glass tubes that we have more recently developed. And then at the same time, what I've had happen is I had one of my colleagues draw the blood from me in a random order. So if you look here at the tubes, first we have an PRF tube, then we have an intraspin tube and also a glass tube. So we go ahead, we have all the tubes there. They're being drawn up in a random order. Okay, so here my colleague is drawing the tubes one at a time. So boom, 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 boom. 1, 2, 3, 4, 5, 6. All drawn in a random order. And then I spin it for an 8-minute protocol. After this 8-minute protocol, I come here and I do the water test to show people exactly what's going on in the tubes. This video is about a year old now. And after the protocol, I just want to show people how much the tubes make a big impact on the clotting, okay? So here I'm going to pull them out. So usually, of course, after the spin cycle, so take a look at this. This is the plain glass tube, okay? After the spin cycle. Nope. 8 minutes. So here you can see there's a big difference here now with the tubes. The actual design in the glass, and you actually understand how the science works. That's a plain tube, right? There was nothing in this one. Expiration date. Okay, so that's where I think, you know, these things here are of course healthier than for patients. These are off-label use, of course. Okay, but again, like I said, look at that. Okay, nothing is changing. Now, if I take the intraspin, okay, it's still liquid. Okay, take a look at it. If I was to shift this, okay, of course it's going to ruin that sample. There's a clot that's there, of course, but you can tell it's not as clotted. And that's got the actual, you know, silica inside of it. That's the plain tube again, that's the other one. Okay, I can keep it upside down, I mean, that's not going anywhere. And so what we saw with that last video was just the fact that, we saw foam that's being produced. We saw different size clots. We saw the clots that you could actually take the tube and reverse them as well. And one of the cool things that happened after that is that, of course, people became interested in some of this chemical-free, very hydrophilic surfaces. And more people started using our tubes. And I started seeing on social media, people started posting photos such as these ones here with the tubes upside down. And right away when I look at some of these pictures, I can tell who's spinning in a fixed angle protocol versus horizontal. So for instance, this image right here in the bottom left-hand corner, I can tell that they're spinning in a fixed angle centrifuge. Here, I can tell that they're spinning in a horizontal centrifuge, right? And you can really see clearly, look at all the red blood cells, pore layer separation versus a nice clean cut with the horizontal centrifuge. And I've gotten a lot of messages since then. For instance, here, I got to admit, these tubes are a game changer, incredible results compared to previously inferior tubes. This one here really meant a lot to me. It's one of my colleagues, did a lot of nice work, was really focused on the tubes, and he said, "Rick, we finally tried your tubes. What a difference. The clots were huge, so much so that there was, that my beautiful assistants could turn the tubes upside down. Way to go, Dr. Miron." And so really cool, the results that people are getting with these new tubes. Again, these are the solid BioPurF tubes that are available, of course, at biopurf.com. Now, since then, of course, we've done a lot of research. It's not just fun and games with tubes that are going upside down. We've been looking at the surface area of the different types of tubes, whether we use plain glass or the silica coated. So the one type of tubes first are the silica coated tubes. And in general, plain glass tubes are 191% bigger. So this has been tested across the board. If you use our tubes versus the silica coated tubes, typically 191%. So in general, 2 times bigger. That's the same protocol, same person's blood. Everything's the same. Only difference is the tube. So again, very dramatic difference here. Now again, the group in Japan, evidence for contamination of the silica microparticles using advanced platelet-rich fibrin, using silica-coated plastic tubes. Take a look at this. These are neotubes, these are vacuette tubes, these are different types of tubes that are silica-coated tubes. And when you actually degrade the fibrin clots and you look at what's left over, this is actually what's left over in these different types of tubes. And this is what's going back in your patient. So this is, you can't tell your patient that this is necessarily chemical free or additive free. It's, there's silica in there. Silica is what's found in glass, of course, and some of these little silica glass particles are being reimplanted back into your patients here. Dr. Kwasi did some nice studies in humans where he was actually looking at cells that were cultured in glass, so pure glass, versus in silica-coated tubes. And you can see really there's a big high affinity for the silica that's being leached out of these tube walls with these cell membranes. So you're starting to see that actually the silica is being incorporated into these cells. These cells are not functioning at the same capacity. And in fact, he's shown through several cell studies that silica actually causes apoptosis. Okay, so there's obviously a little bit of negativity here associated with this. So here's the most recent PRF tubes that have been utilized. Now when we look at this, still in the container here, when we take these out, okay, these right here, what you find is that in a lot of these tubes that make the membranes, whenever they go in, look at that, okay? It makes all this soap-like product, okay? That's, pretty disgusting, of course, if you're going to use this in a patient. And that's not a, random tube. I can take any of these tubes that we have. That's just basically whatever's on the walls there, the silica or whatever. Again, the tube, whenever it goes in, okay? Same thing as it's going in, okay? And again, when you see that, it's quite disappointing to see all the chemical additives that are here. Of course, the company has claimed that it's silicone. They're still unsure at what it is, but in any event, you can see this big foam-like product, and this is from one of our more recent publication, demonstrating foam-like product when simply water is entered into these PRF tubes. Now, of course, then the next question is what's going on with the silicone, and does it affect clotting? And of course it does. And we found actually in our studies that it's actually worse having silicone in these tubes when compared to silica. and the membranes are 224% bigger when we use pure glass. So big differences here. And a lot of people may have seen that the protocols for some of these APRF protocols have changed. And the manufacturer, because the clotting now is decreased, the manufacturer now says, hey, do a 14-minute protocol or a 12-minute protocol as a result of this. And this is just, differences in tubes. Again, with the low-speed concept, we want to go slower for less amount of times. Typically, we do an 8-minute protocol. But the problem is that when you have tubes that are not clotting as effectively, what manufacturers will do is they'll extend the working time or the protocol time in order to try and get a better clot. Okay, so that's something that we found. Now, this is just kind of a summary, and I think it's a very important one, and I'm going to read it literally word for word because I think it's very important. Unlike natural materials that include silica, silicone is a man-made product that is manufactured in factories as solid, liquid, and gel. Silicone is commonly used as a sealant, electrical insulation, and component of cooking utensils. Therefore, even though silicone used for tube coating may contain silica-like compounds, it cannot activate blood coagulation. Excess silicone coating actually delays coagulation. Furthermore, even if silicone has negative effects on the immune system and our cells directly involved in tissue regeneration, these effects should be distinguished from those of silica. In any case, when platelet concentrates are prepared for use of regenerative therapy, we believe that real plain glass tubes that are approved by regulatory authorities of individual countries, regardless of their origin materials, are better for clinical use. And so this is word for word directly out of the Japanese group's paper. I second this entirely. I think that as clinicians, we're always trying to get products that are more natural. And I think that in this case here, when we add silica or silicone, we're actually delaying clotting. And so we're getting smaller clots. And of course, they're chemical additives to tubes that we don't necessarily need. And so what's one of the reasons why at BioPureF we have completely plain glass tubes. The clots are more pronounced, and of course, you can flip them upside down and get nice clots. When you're in doubt, when you're not sure what's inside your tubes, easiest thing you can do, okay, take the tubes, bang them together, see if they're glass, put a little bit of water inside the tubes and do the little water tests. Fill the tube up halfway with water, shake it like crazy, okay, vigorously shake it. If you start to see some foam-like product, there's obviously chemicals inside there. So be aware of that and just inform your patients if you do decide to use those types of tubes. Ideally, what we recommend is using chemical-free, completely no chemical additive tubes.